Welcome to Esther equation corner. So today we want to resolve this math problem. We have x plus 1 times x plus 2 times x plus 3 times x plus 4 all equal to 120. So let's group this into two. We have x plus 1 times x plus 4. We have x plus 2 times x plus 3 all equal to 120. So opening the first bracket, we have this times this. We have x squared plus 4x plus x plus 4. And we want to open this bracket. We have x squared plus 3x plus 2x plus 6 all equal to 120. So from here we have x squared, 4 plus 1 we have plus 5x plus 4, and here we have x squared, 3 plus 2 we have plus 5x plus 6 all equal to 120. So we have x squared plus 5x plus 4. We have x squared plus 5x. We can split this 6 to be 4 plus 2 all equal to 120. So this and this look alike except from these two. We can make x squared plus 5x plus 4 to be equal to k. So it simply means that all this is k times and all this is k plus 2 all equal to 120. So when we open this bracket, we have k squared plus 2k all equal to 120. Let's move this value to the left. We have k squared plus 2k minus 120 all equal to 0. So resolving this with the quadratic formula, we have a to be equal to 1, b to be equal to 2, and c to be equal to minus 1 to 0. So we have k to be equal to minus b plus or minus square root of b squared minus 4 times a times c all over 2 times a. So imputing this value into the formula, we have k to be equal to, we have b as 2 plus or minus 2 to the power of 2 minus 4 times 1 times minus 120 all over 2 times 1. So we have k to be equal to minus 2 plus or minus the square root of 2 to the power of 2. We have 4. We have plus 484. That's 4 times 120 all over 2. So we have k to be equal to minus 2 plus or minus 4 plus 480. We have 484 all over 2. We have k to be equal to minus 2 plus or minus the square root of 484. We have 22 over 2. So our k is equal to minus 2 plus 22 over 2, comma, and minus 2 minus 22 over 2. So we have k to be equal to 20 over 2, which is k equal to 10, and k to be equal to minus 12. So this is case 1. Case 1, and this is case 2. So let's recall that x squared plus 5x plus 4 is equal to k. So for case 1, when k is equal to 10, we have x squared plus 5x plus 4 to be equal to 10. So we have x squared plus 5x plus 4 minus 10 to be equal to 0. From here we have x squared plus 5x minus 6 to be equal to 0. So this is x squared plus 6x minus x minus 6 all equal to 0. So when we factor out x, we have x to be x plus 6. And when we factor minus 1, we have x plus 6 all equal to 0. The values in the bracket look alike. So let's pick the first one, x minus 1. So we'll take one of these, x plus 6, to be equal to 0. So here x minus 1 is equal to 0 and x plus 6 is equal to 0. So we have x to be equal to 1 and we have x to be equal to minus 6. We've gotten two values of x, 1 and minus 6. So let's continue for case 2. When k is equal to minus 12. So we have x squared plus 5x plus 4 to be equal to minus 12. We have x squared plus 5x plus 4 plus 12 to be equal to 0. So we have x squared plus 5x plus 16 to be equal to 0. So let's resolve this quadratic equation, but let's check for our discriminant. Our d is equal to the square root of b squared minus 4ac. Our discriminant is equal to 4 to the power of 2 minus 4 times 1 times 16. So the discriminant, we have 25 minus 4 times 16, we have 64. So d is equal to square root of minus 39. We have a negative discriminant. It simply means that we have a complex number so let's go ahead and verify our question with the previous solution. We got x to be equal to 1 and we got x to be equal to minus 6. So let's verify. Let's record the question. We have x plus 1, x plus 2, x plus 3, x plus 4 to be equal to 120. When x is 1, we have 1 plus 1, 1 plus 2, 1 plus 3, 1 plus 4, all equal to 120. From here we have 1 plus 1 to be 2 times we have 1 plus 2 to be 3, we have 1 plus 3 to be 4, and we have 1 plus 4 to be 5. So this is equal to 120. So when we multiply through, we have 5 factorial to be equal to 120. So we have 120 to be equal to 120. So the right hand side, the left hand side equals the right hand side. So the first value of x to be 1 is verified. So let's check for x to be equal to minus 6. We have x plus 1, x plus 2, x plus 3, x plus 4, all equal to 120. So we have minus 6 plus 1, minus 6 plus 2, minus 6 plus 3, minus 6 plus 4, all equal to 120. So minus 6 plus 1, we have minus 5, we have minus 4, minus 3, minus 2, all equal to 120. 5 times 4, we have 20. This will cancel this. 3 times 2, we have 6, or equal to 120. So we have 20 times 6, we have 120 to be equal to 120. So the left hand side equals the right hand side. So our value for x to be minus 6 is verified. Thank you for watching Esther Equation Corner. Subscribe and hit the notification bell so you don't miss out on any of our solutions.